Hello students, I hope that you are good, well and fine. In today's session, we will be seeing miscellaneous exercise of this chapter 9. Okay, so the first question of this miscellaneous exercise says that for each of the differential equation given below, indicate its order and degree. So let's see the first. So first is d2 by y, d2y divided by dx square plus 5x dy by dx whole square minus 6y is equals to log x. So in order to get the information about order, you must know that highest times we are doing the derivative. As you can see, the 2 times. So this means order will be 2. Order will be 2. Now, in order to get degree, we must know, or we must have a form in terms of polynomial, and polynomial must be in terms of derivatives. Okay. So as you can see, yes, your derivatives, the y prime and the y double prime is forming a polynomial thing. So this means degree will be 1. Okay. Now here order is, as you can see, 1. Order is 1. Degree will be 3. Degree will be 3. Order is 4, but degree cannot define as you do not have polynomial in terms of differential derivatives, in terms of derivatives. Okay, so degree not defined. Now next, we have to verify that the given function is a solution of the corresponding differential equation or not. Okay, so let's see. Clear. So first part, quickly. So y is given like this. Differentiating both sides with respect to x, you will have dy by dx is equals to a ex minus b e power minus x plus 2x. It will be plus 2x. Okay, as you can see, plus 2x. Okay, so little bit, sorry, here this is dy by dx. Sorry for that. Again, let me just do it for you. So y is given this. First derivative will be a ex minus b e minus x plus 2x. Okay, now again derivate this. You will have a ex plus b e power minus x and plus 2. Yes, it is correct, the double derivative. Now substitute into the given thing. You will have what, as you can see, this left hand side is x y double prime plus 2y prime minus xy plus x square minus 2y. Substitute your values respectively. You will get what, 2aex minus 2be minus x plus x square plus 6x minus 2. As you can see, left hand side and right hand side not equal to each other. This means not a solution. Now second, y is this. Okay, now first derivative will be a plus b multiply with ex cos x plus b minus a multiply with ex sin x. Again differentiate it. You will have what, the second derivative will be 2ex multiply with b cos x minus a sin x. Okay, now substitute these. Okay, substitute these. What is your condition? This thing. Okay, what is your condition? This. So you will have what, let me just show you. After substitution in this, you will have, okay, so this will be 2ex b cos x minus a sin x minus 2ex. Okay, as you can see, minus 2ex a plus b cos x plus b minus a sin x plus 2ex a cos x plus b sin x. Now simplifying this, you will have equal to 0. This means this is a solution for the given thing. Now y is equals to this. Okay, y is equals to x sin 3x. Let me just once again give you. Y is equals to x sin 3x. Okay, y is equals to x sin 3x. Now this means what, that differentiate it one time, you will have what, sin 3x plus 3x cos 3x. Now differentiate it again, you will have 6 cos 3x minus 9x sin x sin 3x. Okay, I hope it is clear how we are going to how we are differentiating. We are using product rule, that's it. Okay, now substitute this thing. here you will have it equals to 0. This means a solution. Now fourth thing, x square given to like this, 2y square log y. Differentiate with respect to x. You will have dy by dx as this. Okay. Now this is given to you, the left hand side, x square plus y square dy by dx minus xy. You will have, after substituting your things, you will get it equals to 0. So this will be your solution of the corresponding differential equation. Okay. So only first one was not the solution. Okay. Now next problem. Prove that x square minus y square is equals to c multiplied with x square plus y square whole square is a general solution of the differential equation this. Okay, where c is our parameter. Okay, let's see. So first of all, dy by dx can be rewritten as in this expression. Now, if you try to see, if you substitute your x as lambda x and y as lambda y, then you can easily see that it is your homogeneous equation. So if this is your homogeneous equation, then it can be solvable by using substitution. What substitution? Y is equals to vx and dy by dx is equals to v plus x dv by dx. These two substitution you have to make. You will get your new equation in terms of v and x as this. Okay, cancel the terms, whatever are getting cancelled. Rearrange the terms and use the variable separation thing. You will have your equation like this: vq minus 3v divided by 1 plus v power 4 dv is equals to dx by x. This right hand side can be easily solvable as log x plus log c, some c prime, which is some constant you can say. And this left hand side you have to apply what? This left hand side you have to apply different approach. What approach? Let me show you. So take this as what? V cube y divided by 1 minus v4 as I1 and just v divided by 1 minus v power 4 as I2. So this means this whole integration can be rewritten as I1 minus 3I2. Now, in order to find I1 and I2, what we will do? We will substitute 1 minus v power 4 is equals to t. This means vq dv is equals to minus dt by 4. This means I1 can be rewritten as minus dt divided by 4t. This means minus 1 by 4 log 1 minus v power 4. This will be your I1. What about I2? I2 can be rewritten as v dv divided by 1 minus v square whole square. Now put v square as p. This means dp by dv. Okay, or v dv is equals to dp by 2. This means you can replace v dv as dp by 2. This means half of integration dp divided by 1 minus p square, and you know the direct integration, which is 1 divided by 2 multiply a log a plus p divided by a minus p. Okay, clear? Okay, is equals to 1 by 4 log 1 plus v square divided by 1 minus v square. So your I1, I2 substituting back, you will get your this integration as this. Now substitute again. You have to substitute your things in terms of x and y. So after substituting, after applying your log things, you will have your final answer as x square minus y square is equals to some parameter c multiply with x square plus y square whole square, where c, capital C, is what we are taking, this c prime square thing. Okay, that's it. Okay, I hope it is clear. Okay, let us move next. Now fourth problem. Fourth problem is that find the general solution of the differential equation this. So let's see. This can be easily solvable by just separation of variables, as you can see. So you are having dy by root of 1 minus y square is equals to minus dx by root of 1 minus x square. This is sine inverse y. This is also minus sine inverse x. So you will have sine inverse x plus sine inverse y is equals to c as your general solution. Now fifth problem. Show that this differential equation solution, general solution, is given by this. So let me just show you. So dy by dx, this can be rearranged and can be solvable by using separation of variable. So rearrange the term accordingly. Now integrate both sides. You will have integration of this term plus some constant. This denominator can be changed, reduced in what form? By using the method of completing square. You will have some a square plus x square form. This means you know the direct integration of that form. So we will be using the completing square method and then the direct integration. Okay, so you will have 2 divided by root 3 tan inverse y plus 1 by 2 divided by root 3 by 2 plus 2 root 3 2 divided by root 3 tan inverse x plus half divided by root 3 by 2 is equals to some constant. This means apply tan inverse a plus tan inverse b formula. You will get this. Okay, clear? Rearranging, I am not going into the depth as steps are already given here. Please prefer them. I am just going to the last step, which is x plus y plus 1 is equals to 2b divided by root 3 1 minus xy minus 2xy. This means x plus y plus 1 is equals to a multiplied with 1 minus x minus y minus 2xy, where a is equals to 2b by root 3, as you can see here. Okay, x plus y plus 1 is equals to a multiply 1 minus x minus y minus 2xy, where a is our parameter. So we have showed that, we have proved it. Now sixth problem. Find the equation of the curve passing through the point 0, 4, pi by 4, whose differential equation is this. So try to standard this form. So it will be what? This can be rewritten as, if you change it, you will have dy by dx as minus sin x cos x divided by cos x sin y. You can use the variable separation thing. You will have tan x dx plus tan y dy is equals to 0. Okay, this gives you what? This gives you, you can directly integrate it. You will have integration of tan x dx plus integration of tan y dy is equals to some constant. This means integration of tan x is log of sec x and this is log of sec y. Use the log property. You will have log sec x sec y is equals to log c. This means sec x sec y is equals to c. Now substitute x as 0 and y as pi by 4. So 0 means 1, pi by 4 means 1 by root 2. This means just root 2. This will one product with root 2 is equals to c. C value will be root 2. This means the particular solution will be sec x sec y is equals to root 2. Okay, I hope this is clear. Or the another way to represent this as cos y is equals to sec x divided by root 2. Okay, clear? Okay, let us move next. Seventh problem. Find the particular solution of the differential equation 1 plus e power 2x dy plus 1 plus y square ex dx is equals to 0, given that y is equals to 1 and x is equals to 0. Clear? So quite simple. First of all, what we will be using, the variable separation thing. As you can see, you can write it like this. Integrate both the sides. You will have tan inverse y plus integration ex divided by 1 plus e power 2x is equals to c. Now ex, replace it by t. You will have e 2x is equals to t square. Derivate this, you will have ex dx is equals to dt. This means numerator can be directly replaced. You will have this form, integration of dt divided by 1 plus t square, and this integration is tan inverse t. This means tan inverse y plus tan inverse t is equals to c. This means tan inverse y plus tan inverse ex is equals to c. Now substitute your conditions. x0 y1, x0 tan inverse 1 is pi by 4. This means pi by 4. Pi by 4 plus pi by 4 is equals to c. This means pi by 2. C will be your pi by 2. So your particular solution will be tan inverse y plus tan inverse ex is equals to pi by 2. Clear? Now eighth problem. Y e power xy dx is equals to x e power x by y plus y square dy. Solve this. So what you have to do? Quite simple, as you can see. You can write this as what? You can write this as in this form, that y e power x by y dx dy is equals to x e power x by y plus y square. Okay. Now, rearranging some terms, you will have what? E power x by y multiply with y product with dx by dy minus x divided by y square is equals to 1. Now what we are trying to do is substituting this e power x by y is equals to z. Now substitute e power x by y is equals to z. This means derivative of this with respect to y. We are taking derivative with respect to y will be dz by y dy. This is this. Now derivative of this will be e power x by y. Now derivative of this will be y square. Y denominator will be y square. Using quotient rule, you will have numerator as y product with dx by dy minus x. Okay, clear? I hope it is clear to you. Okay. Now this means this whole left hand side thing is dz by dy. This means, and we know the left hand side is already equal to 1. This means dz by dy is equals to 1. This means dz is equals to dy. This means z is equals to y plus c. This means z is what? E power x by y is equals to y plus c. So your general solution will be e power x plus y is equals to y plus some constant. Now ninth problem. Particular solution, we have to find the particular solution for this, where y is equals to minus 1 when x is equals to 0. Hint is already given that x minus y is equals to t. Put x minus y is equals to t. So first of all, what we have to do? Rearrange the term so that you will get dy by dx is equals to 1 minus x minus y. Okay, divided by 1 plus 1 plus x minus y. Now substitute x minus y as t. You will have derivative of this will be what? This will gives you 1 minus dy by dx is equals to dt by dx. This means 1 minus dt by dx is equals to dy by dx. This means you will have what? 1 minus dt by dx is equals to 1 minus t divided by 1 plus t. This means dt by dx can be rewritten as 2t divided by 1 plus t. Okay. This means rearranging some terms, cross multiplication, you can have the method of separation of variable. So 1 plus 1 by t dt is equals to 2 dx. This means integrate both side. You will have t plus log t is equals to 2x plus some constant. Substitute your t value back, which is x minus y. So your final general form in terms of x, y will be log mod x minus y is equals to x plus y plus c. Now substitute your particular conditions to get the particular solution. So x0 y minus 1, x0 y minus 1, this means 0. This will give you c is equals to 1. So c value will be 1. So particular solution to the given differential equation will be log modulus x minus y is equals to x plus y plus 1. I hope this is clear. 10th problem. Solve this differential equation. Okay. So in order to solve this, first we have to know that dy by dx can be rewritten as e power 2 minus 2 root x divided by root x minus y divided by root x. Rearrange some terms. This means this form, now you can have an idea that this form is a first order linear differential equation. This means p will be 1 by root x, q will be this term. P will be 1 by root x, q will be this term, right hand side term. Integrating factor will be e power 2 root x. Integrating factor will be e power 2 root x. Now use this. Y integrating power is equals to integration of q multiply integrating power dx plus some constant. You will have y multiply with e power 2 root x is equals to integration of 1 by root x dx plus some constant. This integration we directly know that y e2 root x is equals to 2 root x plus some constant will be your final and the general solution for the given differential equation. Okay. Now 11th problem. We have to find the particular solution of this differential equation where condition is y is equals to 0 when x is equals to pi by 2. So let's see. P is equals to cot x, q is equals to 4x cosec x. Okay. Integrating factor will be just sin x. Okay, integrating factor will be just sin x. Y integrating factor integration q integrating factor dx plus some constant. Y sin x is equals to integration of 4x cosec x sin x dx plus some constant. Y sin x is equals to 4 integration x dx plus some constant. Y sin x is equals to 2x square plus some constant. This will be your what? General solution. Now, in order to get your particular solution, substitute these values. X as pi by 2, y as 0. This means pi square by 2, c will be minus pi square by 2. C will be minus pi square by 2. This means your particular solution will be y sin x is equals to 2x square minus pi square by 2. Okay. Now, 12th problem. Find the particular solution. Okay. X plus y 1 dy by dx is equals to 2 e power minus 1 minus 1. You can use separation of variable. Applying separation of variable, you will have ey dy divided by 2 minus ey is equals to dx divided by x plus 1. Now you can directly integrate both sides. The right hand side you will get log of x plus 1 plus log c. And the left hand side you will do the substitution method, which is 2 minus the denominator we are taking as t, which is 2 minus e power y is equals to t. This differentiated you will have minus dt as e power y dt. Sorry, dy. It will be dy. This means you can directly replace your numerator. This will be just integration 1 by t. This means the direct answer will be what? Minus log t. This means minus log 2 minus e power y. And this is we already have. We just use log properties. You will have, after using log property, you will have 1 by 2 minus ey is equals to c multiply with x plus 1. This means this as your general solution. Now substitute your values. X is equals to 0, y is equals to 0. This means x0, y0 will give you 1 by c is equals to 1. So 1 by c is equals to 1. This means c is equals to 1. So your particular solution will be ey is equals to 2 minus 1 by x plus 1, or rearrange some terms, use the log exponential properties. You will have y is equals to log mod 2x plus 1 divided by x plus 1 as your particular solution. Clear? Okay. Now 13th problem. The general solution of this, let me just quickly show you. So y dx minus x dy divided by y is equals to 0. Y dx minus x dy divided by xy is equals to 0. This means 1 by x dx minus 1 by y dy is equals to 0. This means to integrate both sides, you will have log x minus log y is equals to log k. This means using log property, you will have x by y is equals to k. This means y is equals to cx, where c is equals to 1 by k. So option C will be correct. As you can see, y is equals to cx will be your answer. This. Okay. Now 14th problem, general solution for this. Okay. You directly know the general solution for this, which is x multiply with integrating factor, which is e integration p1 dy. This C option will be the correct. You already know the form. Okay, this is just direct thing. Okay, now 15th problem, the last problem of this chapter, and also for this miscellaneous exercise. Okay, then we are done with this chapter. We will be moving to the next chapter, vector algebra. Now the general solution for this differential equation will be what? Let me just quickly show you. So dy by dx plus y is equals to minus 2x e power minus x. We can rewrite our differential equation in this form, and this is first order linear differential equation where p is 1 and q is minus 2x e power minus x. This means integrating factor is just ex. Use this form to get the general solution. So y ex is equals to integration minus 2x e power minus x multiply ex dx plus some constant. You will have y ex is equals to minus integration 2x dx plus some constant. Y ex is equals to minus x square plus c. Y ex plus x square is equals to c. So this means c will be your final answer. Y ex plus x square is equals to some constant. Y ex plus x square is equals to some constant. Option C will be the correct. So this is it for now. Okay. So I hope that you got something new while studying this chapter, differential equations, how to solve them, what are the different methods. Okay, so this is it from our side for this chapter. Okay, so thank you all. We will be back with a new chapter again. Thank you.